Before we begin, if you want to go deeper into timber than what's published publicly, there's a link in the description to join the email list. Subscribers receive carefully researched ebooks, long-form videos showing real woodworking and timber projects built step by step, and material-focused content that isn't released anywhere else. It's quiet, detailed work shared directly. Now let's get into it. Most outdoor wood fails not because it gets wet, but because it stays wet. There's a quiet assumption in modern building that wood outdoors is doomed unless it's sealed, wrapped, pressure-treated or chemically protected. That assumption feels sensible, but it's historically backward. For most of human history, timber structures lived outdoors for generations, without plastic barriers, synthetic preservatives or factory treatments. Some of those structures still stand today, while modern builds often fail in a fraction of the time. The uncomfortable reality is that many modern timber failures aren't caused by exposure. They're caused by interference. Builders try to stop wood from behaving like wood, and in doing so, they create the exact conditions that accelerate decay. The trick old builders relied on was not secrecy or lost chemicals, it was understanding moisture movement and allowing wood to dry on its own terms. Once you see that pattern clearly, you start noticing how often modern construction works against it. Wood survives outdoors when it is allowed to breathe and drain. Wood is not inert, it absorbs moisture from the air, releases it again, swells, shrinks, and equalizes with its surroundings. That movement never stops, even in a dead tree turned into a beam. Outdoor timber fails when this cycle is interrupted, not when it occurs. Traditional builders paid close attention to how water moved across a surface, how air circulated around a joint, and where moisture would linger after rain. The goal was never to keep wood dry all the time. The goal was to ensure it never stayed wet long enough for decay organisms to establish themselves. Fungal decay requires three things: moisture above a threshold oxygen and time. Remove any one of those for long enough and decay stalls. Old-world builders couldn't remove oxygen, and they couldn't control weather, so they focused on time. Water was allowed to touch the wood, but not to sit in it. That single principle explains centuries of durable timber construction far better than any modern product label. One of the most ignored outdoor timber protection techniques is also the simplest: shaping. Old builders beveled edges, crowned horizontal surfaces, undercut joints, and avoided flat ledges wherever possible. Water was encouraged to leave the wood immediately, not trapped for later. Modern lumber is milled square, installed flat, and sealed as an afterthought. The geometry invites water to pool, and the finish tries to compensate. When that finish inevitably fails at a joint, fastener, or even a tiny hairline crack, moisture enters but cannot escape easily. The wood stays damp way longer than untreated timber ever would. Historic timber frames, fences, gates, and exterior cladding often show deliberate tool marks and subtle angles that, at first glance, look decorative until you understand their function. Those surfaces are actually doing quiet work, directing water away from vulnerable fibers and joints. This is not nostalgia, it's material logic. Another modern assumption is that wood touching the ground must be treated or it will rot. But old builders knew better. They simply avoided direct ground contact whenever possible, and when they couldn't, they made different material choices. Posts were set on stones not buried in soil, sills were raised on masonry, timber bridges rested on sacrificial sleepers designed to be replaced. When wood did meet earth, species selection mattered. Dense, resin-rich woods were chosen not because they were indestructible, but because they slowed moisture uptake and decay long enough to be useful. Chemical treatment attempts to override soil biology. Traditional construction worked around it instead. Once you understand this, you begin to see how many modern failures come from convenience-driven shortcuts rather than material necessity. Old-world timber use paid close attention to which part of the tree was being used and how it was oriented. Sapwood, which absorbs moisture more readily, was often removed or placed where drying was fastest. Heartwood was reserved for structural or exposed rolls. Grain orientation mattered as well. Boards were oriented so growth rings shed water rather than collecting it. End grain exposure was minimized or protected with overhangs and joinery details, not coatings. Modern construction often treats all wood as interchangeable once it leaves the mill. That mindset erases distinctions that older builders considered fundamental. When those distinctions are ignored, finishes are expected to compensate, and they rarely do for long. You know, there's this common misconception that historic builders were always soaking wood in oils, pitch or tar. But actually, in reality, those treatments were pretty situational and often just limited to areas that were really at high risk. When they did use these treatments, they were breathable and renewable. Definitely not those film-forming barriers we see today. Pine tar, linseed oil and lime washes didn't create a waterproof shell either. Instead, they just slowed moisture exchange enough to reduce rapid saturation, but still allowed the wood to dry out properly. Reapplication was always expected, and honestly, surfaces were designed to make that process easy. Now, modern coatings tend to promise permanence, but traditional treatments assumed you'd have to maintain them and were designed with that in mind. That difference in philosophy, I'd say, matters even more than the chemistry itself. Many so-called modern improvements actually create decay conditions that old builders went out of their way to avoid. Plastic wraps, impermeable membranes, tight metal fasteners, and composite assemblies, these often trap moisture right at the interfaces. The thing is, water can get in through even minor flaws and then just stays there, hidden, until the damage is well advanced. Older construction accepted that water would get in. The response was to give it a clear exit path. Open joints, drainage gaps, and airflow were not signs of poor craftsmanship. They were intentional safeguards. This is especially relevant for outdoor furniture, sheds, decks, and small structures where modern standards are often applied without understanding the material consequences. The real trick is designing for failure, not pretending failure won't happen. Historic timber construction assumed parts would eventually wear, soften, or degrade. The solution was not to prevent all decay, but to control where it occurred and how easily it could be addressed. Sacrificial elements, replaceable components, and access for repair were normal. Modern builds often bury critical joints behind finishes and assemblies that make inspection or repair difficult until replacement is the only option. Durability is not just about how long something lasts untouched. It's about how gracefully it ages and how realistically it can be maintained. Understanding wood behavior is a survival skill, not a nostalgia project. Whether you're building a fence, a shelter, a timber frame, or simply trying to make something that lasts outdoors, the principles remain the same. Wood wants to absorb and release moisture. It wants air. It wants time to dry. Old world builders didn't defeat decay. They managed it. That knowledge didn't disappear because it stopped working. It disappeared because industrial materials promise shortcuts. Those shortcuts come with trade-offs that are becoming harder to ignore. Understanding how timber behaves over time changes how you build, how you repair, and how you judge what will last. It reconnects modern work with centuries of observation, trial, and quiet correction. These ideas are not about rejecting modern tools or materials. They're about respecting the limits of wood and working with them instead of against them. If you want more in-depth material like this, including long-form explanations, project breakdowns, and historical research that doesn't fit into public videos, you can join the email list using the link in the description. That's where the deeper work lives. Thanks for spending this time with Old World Timber.